Hello, um, my name is Joseph Itopa Abubakar. I'm a lead machine learning engineer at Renewable Africa, and as part of our Python Introduction to Python series, this is the third session, and our intention is, of course, very clear to put you through the tutorials to put you through the whole lesson so that you can understand how to go about Python. From there, we'll promote you to the one-on-one tutorship on machine learning, natural language processing, computer vision, and the rest through the volunteering assist of our experts. Okay, for today, I will let me share my screen. Okay, I will be we'll be discussing Python, but since we didn't finish last week, we'll just quickly go into that. The link to the code on GitHub will be shared below this video um, on YouTube. Yeah. So let me go ahead. So you just click on Google Colab or you search for Google Colab. This is the third week. We assume you should know it, but for those who have not been participating, just type Google Colab. I think let me show that to you before I continue. Just type Google Colab. Yeah, that's it. So when you do, you click on it. So Google Colab is actually an environment that supports Python codes, so it can help us interpret our code. But in your case, you just have to click on GitHub once you're there. Okay. Then you paste the location of the code. You paste the link to the code, and we hit enter. Okay, it's like I did something wrong, so let me quickly correct that. Okay. So you click on GitHub, and then you paste the path or the link to the path and search. Could not find organization or user. Okay, it's loading, so we don't have issues. We'll definitely repeat this process for our third webinar series, but we'll have to do a bit of some work on the previous lessons, especially the webinar series 2, that is the second webinar series, and that's because we had we stopped at some point. So let's quickly take a look at it, then we'll go to the main objective of today. though we encourage you to practice it on your own, but we cannot say if you do. So we just quickly take a look at it. And that was on, we stopped here, list, dictionary, and tuples. So how you can build your list, your dictionary, tuple, how you can build it with data, and of course, understanding how to structure out the data. So basically, we're going to talk about data structure and data type. Though we've talked about this before, but we're taking a step further into it. So first is building a list. What you have here, you have three values, two values stored in a list. For a list, we use square brackets that identify that it is a list, and the member of the list is what, 3 and 6. And we have another variable here with 3 members. So we can sum the member of a variable of a list together. So it's very easy. That's what lists can do. So we can sum the member of what we are actually doing. We are not aggregating the value of the list. We are only trying to stack what is stored in the list. So that's what we did here. We stacked them together. Then another beautiful part of list is that you can store numeric values as well as string. So, and if you still decide to stack them together, it will work. That's another good example of list. So for a list, you can also use the range method to define a number, to define certain range of numbers. Then we have a step size, and this is the step size you can see here. First, we declare an empty list, nothing is stored inside. Then we pass range into it, and that range has beginning, which is 1, and the end of it, which is 20. And then you have a step size, which is what it increased by. So we can do that with list. It's not abominable, it's not an abomination, so it will work. Then we have let's talk about the member of a list. We can do this using range to fill a list, and we can now say, okay, print out the member stored within the list, starting from -3 to 25. Now, in a case where you do this without putting the step size, it is assumed to be 1. So the next thing, we start to print out these the members of the list, because we're using an if statement and saying if I in list 3. So we are saying for everything that is in that list, print it out. Let us take a look. So he's going to do this. He's going to start from -3 and continue -2, 1, 0, like that. But as the for loop is looking through the number from -3 to 21 with a step size of 1, then the if statement helps to check if any of the number within the for loop belongs to the list build 3 variable where we store this stuff. So it checks for 0. 0 is a member of this, of course. Obviously, you can see there's 0. So 2, 1, 2, 3, 4, they are not part of the list member because of the way we declared it here, the range. 0, then 5, then 10, 10, 15, till you get to 25. So that was the last number here is 20. So when we do that, you realize that with the if statement, we can actually bring out some part of a particular type of numeric value, not all of them. So, and in this case, it says, since we have a step size of 5 starting from 0, that's what you will see when it starts from -3 to 24. So so that we don't waste much of our time, we can go to the thing of the day. Let me quickly rush through this. We also have list bounds. The essence of list bound is to do what? To tell us if you have if the members are within the bound. So for this example, when you run it, you have an error, and the error is okay, out of bounds access. It soon pop up. Okay, list index out of range. What does that mean? It starts from 0. The address to this, or the storage location, starts from 0, 1, 2, 3, and 4. And what we are pointing at is 7. So as long as it's not, the member of the list is not up to 7 or 8, it will not be able to print it out for us. So if you check it again with another number, let's say you pick 3, you should bring out 20. Yeah, you see 20. It starts from 0, 1, 2, 3. So that's the essence of this bound. This can have bounds. Then we can also slice a list. Slicing simply means we are taking some part of the members, we are taking some chunk. Okay, we just want to see this, we take it out. That's slicing in list. And in this case, 0 to 3, we are simply saying, okay, from here to this 0, 1, 2, and 3. So that's what we want to view, if I am correct. Okay, the last one is always ignored, rather. The last one is always ignored. That's for list. So we do that, and then we have all of this. This is just manipulation of the list. And one other thing you need to notice, if you want to reverse the list, you use this. That is the ternary operator, which is the double colon and -1. That will reverse the list from it start counting it, or from the back, start printing them out from the back. So do not forget, for a list, we have the beginning, the end, and the step size, if we're using also the range function to identify it. So these are further examples which we assume that you practiced. You know, the members of a list are not just numeric values, they can also be string or characters, as you can see in this place. So we can also play around by slicing them to pick some part and play with it. So that's what you see here. Okay, there are other methods that can be used with list, or they are regarded as list method. The count, it helps to return the number of time a given element appears in the list. You can play with it. We have the insert, to insert a new member into the list, or a new element into the list. Then we have the append, which helps to modify the list, adjustment. Yeah, so we have the index, and remove, reverse, and sort. That is sorting the list either in ascending order or descending order, whichever way you want to see it. So we have some examples here. I will not I will just run them, but I will not give it much of a time because we have to go to what we have to do today. So append this, before it has no 3, 4, 5. So when you do append, it has 3, 4, 5. And when you do remove, the list method remove helps to remove the 3, 4, 5. And then we have the count as well. When you count, how many times does ABC appears? 1. That's the essence of the method. It's very fine, it's very beautiful, you can enjoy it. And then we have the metrics. Metrics are identified in a list format, or they are structured in a list format. So when you are doing NumPy, PyTorch, the rest, the data are always in the form of a list. So we'll talk about that towards the end of the webinar series. Then you can also build tuple, building tuples, slicing tuple, and modifying tuples. Okay, first we'll talk about building tuple. List uses square bracket, while tuple uses what? Curly brackets. So that's basically the difference, and they also have further difference which we'll talk about soon. Then we can print the member of a list. You can access each element of a tuple rather. So if you do that, remember I said the count starts from what? 0. So put 0 in here, it tracks this down and bring the value stored in that address. So we can also slice through tuple. When we do that, what do we have? Very similar to list, so it's not confusing. But then the difference between list and tuple, another difference between list and tuple is what you see here. You cannot modify the data stored in a list, in a tuple rather. Tuples are stored, you can't modify the data in it. So we still have some stuff for you to play around with. The difference between list and tuple, um, using some features. Okay, list is mutable, meaning it can be modified. Tuple, it can't be modified. And there are some addition, removal, all those are modification. They are not possible in tuple, they are possible in list. And you can access list as well as you can access tuple the same way. And what else? Slicing assignment. You cannot slice okay, you cannot slice a list, a tuple, and assign it to a variable because it sends it as modification, so it's not allowed. So we'll briefly talk about dictionary. Dictionary consists of key value pairs. It is enclosed by curly brackets, and then the stored values can be accessed using square brackets, just like list and tuple. So the point is that for a particular dictionary, you have the key, and then you have what is stored um, in it. So you can use the key to access what is stored there. Basically, that's what it is. So, and that helps to give it some level of security. And then we can build a dictionary, and you can use the type method to check to know what type of um, data it is. So in this case, the data is a dictionary. So we can also play by building this building dictionary. We have okay, I declared an empty dictionary here. It has no element. So here I decide to fill it. So you can fill it, and then at the end of the day, okay, my age is not 51. I think I was just playing around. So but it's 51 in case you intend to pay me pension. It's 51. So just run this. We can build the member of the list, and then if we can print out a particular element, in this case marital status, Python. Oh, how are you going to get married to a Python? Okay, all right, so that's just it, is for the fun of it. So you can print out the member of a dictionary, and then slicing through dictionary is also very possible. It's possible, but it's a little bit different from the normal way you slice through list and tuple. In this case, it's quite difficult. So you have to do some kind of use for loop and then the in keyword to search through, and then print out and to slice. Yeah. So you can modify dictionary as well, but you have to pick the key. So if you look at this example, we pick the key cat, and then we change it. We change the value stored there, which is gray to red. So you can do that with tuple. So we have this assignment here, which we believe you go through, but I won't waste much time on it because we'll go straight into exercise 3, the third week of this webinar, so that we can talk about it properly. Okay, so that is that. I just have to rush the tool and go into this. So Today we'll be talking about Python functions and methods. It's very awesome if you get to understand Python functions and method, because that's what will lead us to object-oriented programming, whereby we'll talk more about um, classes, how to implement classes. So, okay, it's almost there. So, okay, before we begin, we gave you some exercise to practice with, and we have create a program that reads two integers a and b from the user. Your program should compute and display the sum of a and b, the difference when b is subtracted from a, the product of a and b, the quotient when a is divided by b, the remainder when a is divided by b, the result of log of a, and the result of a to the power of b. The only place where we had a mistake is that the difference when b is subtracted from a. Okay, it's correct. So we just begin by instantiating the two variable a and b with zeros. Then we pass in the inputs, and then the next thing we print out the solution direct to the point. So the sum of a and b, the difference between a and b, the multiplication of a and b, the division of a and b, and then the modulus of a and b. That's what gives you the remainder. Then we are using this library. Gradually we are introducing you to libraries. Libraries are packages. They are Python packages or modules that you can call or invoke and make use of in your code. So since it has this log, because log is not something you can just you have to understand the basic mathematics of log before you can implement it. And if we intend to do that, it will have more lines of code. So all we just need to do is import this library, and then we invoke the method log.log from the math library, and then we do what we want to do. This is the one we want to find the log of. This is the base, which is 10. So after that, we do that, which is to the power of b, a to the power of b. This is like saying 2 raised to the power of 2. If a is 2 and b is, okay, let's say a is 2, b is 3. 2 raised to the power of 3. That's what we are doing here. So to the power of is double asterisk. So that is what we expect you to have tried and possibly gotten answer to. So while that is coming up, we'll talk about example 2. The Chinese zodiac assigns animals to years in a 12-year calendar. Okay, while we are, let me hit this, and then it requests for this. I hit that. Okay, if you sum them together is 7, the difference is 3, the product is 10, the division is 2.5, the result of the remainder is 1. And yeah, because 2 into 5, it will divide 5 twice, then it's remaining 1. So you have this one, then the log is what you have here, and the result of a to the power of b is 25. That is 5 to the raised to the power of 2. So example exercise 2, we're talking about the Chinese zodiac, which is the Chinese zodiac assigns animal to years in 12-year cycle. One 12-year cycle is shown in the table below. The pattern repeats from there, with 2012 being another year of the dragon and 1999 being another year of the hare. I don't, maybe Harry, maybe hare, it depends on how they pronounce it. Write a program that reads a year from the user and displays the animal associated with the year. Your program should correctly for any year greater than or equal to 0, not just the ones listed in the table. So first thing we do, we instantiate the year with 0, even though we are starting with 0. So each one of these, we have to be able to identify what particular, is it the 4th year, is it the 5th year, is it the 6th year in the cycle. That's what will help us to pick the animal equivalent. So we are using dictionary in this case. So we just receive the input. After receiving the input, we search the dictionary and then we print out the solution. So we run this, and then okay, let's say 7. What do we get? Okay, pig. And let me try it one more time. Let me see, 32. What do we get? You enter 30. The number is out of Chinese years. Okay. uh, because the Chinese year is a cycle and is 12. So we have 12 years. So you can't be entering 32 except you want to change the Chinese culture. So we'll go to the third exercise, which is write a program that computes the body mass index of an individual. Your program should begin by reading a height and weight by the user. Then it should use one of the following two formulas to compute the BMI before displaying it. If you read the height in inches and the weight pounds, then body mass should be computed with this formula. Or if it is in meters and in weight, and the weight is in kilograms, you can use this. You don't need the conversion constant, which is 0.73. So first thing we did, we instantiate the variables and then we read the inputs. The height is an integer, the weight is an integer, the height is float. So we just perform the basic arithmetics required of us. So we can just say 45. Oh no. The last time I checked my weight, I think I should be 61, but I am not sure. Then the height, of course, I know it can't get any worse or better. I should be at that. So you can see you get this as your BMI. So I don't know how to interpret BMI. Let me be sincere with you, but that's that for that. So we are going into today's discussion, which is introduction to Python programming, functions and method definition. So we're going to talk about this. And under functions and methods, or method definition, because functions are basically methods. We have what are functions, how functions operate, type of functions. Then we'll go ahead and talk about function parameters, using loops with functions, generators and decorators. Then we introduce you a bit to classes, because that's what we're going to do in 2 weeks time. Object-oriented programming, and it's centered around classes. So what are functions? Well, a function can be defined as at a point in a program and invoke at some other point within the same program. So the point is this: a function is just a piece of code designed to perform a particular task. So whenever it is needed, the function is invoked, and then it carries out the duty, and then breaks out of the goes back to the program, and the programs keep running. So let me use this to explain better how functions work. For instance, we have a program that is running, but then we have defined a function here earlier, and we are using the keyword def. That's what Python used to identify that this is a function. So def function name, then this. So we use this function name. Then when we start the program, at the point we needed the function, so we invoke it this way. So after invoking it, doing what it needs to do, the programs continue to run. If we need it again, we invoke it. It calls it back to do that particular task to that point. So there are basically 2 types of functions. We have the user-defined functions and we have the built-in functions. The built-in functions are the ones that developers like you and I, and then those that are in love with Python, decide to build a particular piece of code to perform a particular task, package it, upload to PyPy, and of course anyone can call it as a library. So, or it can be packaged with Python as a whole. So whoever installs Python can have access to that particular chunk of code to do that task. As said earlier, the syntax is very simple. Def is very important. That's what a function starts with. And the reason why def is because Python needs to know that it is a function. That's why you have to put the def there. Then the name of the function, then the parameter list. Parameter list actually is telling you that, okay, what is the function, what are the arguments, the variable that the function is dealing with. In most cases, there are some variables declared within this which are called parameter list. So you can have multiple, you can have single. So you just have the variables stored inside that function. That is what is manipulated. So anytime you call the function, you pass in value to that variable, then the function uses those values to carry out its computation, then give you feedback. Then this block is where you drop your chunk of codes. That's Python statements. That's where you find the codes. So I have basically explained that. Then we now give a short to our first code, our first function. So we call it def, and the name is print message, and it has no parameter. So basically, when we call it, it just does what is inside of it, which is this statement of block, or this block of code. So we run it. Okay. Then we invoke it by calling the name with these two brackets. One bracket rather, that is one, that's not two. Okay. So here is it. You can see that the statement in the code has been printed out. We can go ahead and say, all right, let us give it a further shot. How about we have a variable here? This is a single parameter, and then we said, okay, this parameter is what we are going to use to invoke. Is what we are going to be sending some values to, so that the Python the function can execute it. So you do this, nothing, and if you do, okay, if you intend to invoke it, you will see my message. Okay, you say this. You see that the error is missing one required positional argument message. So you have to feed it with a value before it can execute. So in this case, if you come here, you see that we had the value here. So we pass in this, because if you see the function itself, print my MSG, is asking for, it has a parameter or an argument. So it's asking for something. You have to feed it something like this. So mind you, it is one that we declared, and we can declare multiple in it. We can have something like this, B, C, D, something like that. But here we only had one. So just to have experience of what we're talking about. And also you need to understand that when we do this, the function doesn't keep record of this. No. As we pass in this value, or this string, as we pass in this string, what happens is that the function takes the string, process it, or executes it. That's all. The function doesn't store it. And that's when we will talk about that under generators. Under generators we'll talk about how to maneuver that, because it's very important. So we can have here You see, we declared set square of n, and in it we have the return method. The return method actually returns the result of our computation. So when we call square, we have to pass in an argument. We have to pass in a value, the variable itself, the value to be stored in the variable before the function can process it. So we do this and then we run that, and we have 25. So what happens if you now do this? You see, it throws an error. The error is that square takes one position argument, but two were given, which is true. We gave two. Look at it, 5 and 6. And what we declared in it is what? Only one. Um, Only one variable or parameter. So it can only take one value. So we have to remove one. Let's say I take it with 5 and then I run it again. What do you have? 36. So that's basically all about parameters and return keyword. Return keyword is very important. So we can also do swap values. In this case, we have two variables. Our function has two parameters, so we need to swap it. But in order to swap it, we're using the return keyword, and we are now saying that okay, once you pass in those variables to the swap function, return them in reverse order. So we can try it. Already, we are invoking it here. We are invoking our function at this stage. That's what we are doing. That's what we've been doing here. But I believe that you are used to it, so I don't need to move this to a new line. I believe you understand what this should be. So we just run it, and that is it. You see, we pass in 5 and 7, and we got 7 and 5. That's basically what it is all about. And of course, so whenever we write a function or a Python function, there are ways of documenting functions because other people may be interested in improving your function, and of course you at some point in the future may also be interested in improving your code, and you cannot tell me that you will remember everything you did, so you have to document it properly. And one of the structure of documenting Python function is what? The sole aim of the function. Ensure you identify it, you note it down, then the role handled by every parameter in the parameter list. In this, as we're talking about that, these are the parameters. So you have to document the role that each of those parameters handle or take. Then explanation of the nature of the return value in the block, which is this, because the return value is actually what returns the result of the function. So you have to also explain that. So those are the three basic steps you need to take, and your Python function will be properly documented for anyone to easily understand or participate in. So we'll now talk about the built-in functions in Python. We've been using print, and it has been very sweet, right? Yeah. So the print function actually helps to print out the results, and it has been defined, it has been implemented, it's there in Python. You just use it. We've been using it from the first webinar. And then we also have the input function, which we also have been using in our exercises to take inputs. So it's a method which is very okay. Many people use it. It's lovely. I love it as well. So we have other built-in functions like eval, which is for evaluation, then execute, which is for execution. But you have to be very mindful of using these two, especially when you grow from amateur to maybe professional or something like that, and you now code Python in a Linux environment. Be very careful what you use eval and exec for, because it can make your users to have access to your computer or to manipulate your computer. All they need to do is to pass a command to this, maybe a deleting command or something else. They'll pass it to it, and before you know, these two can execute it on their own. So that is if you intend to, if you write a code in your computer and you know people will use it, be mindful of using this tool. Is very, very important. So then this is an example of the eval. The eval basically just goes, evaluates, and that's all. So it has that in the background. We are saying x plus 1. So what eval does not see this as a string. No, it picks what is inside the string, then process it. So that's why we have this. And if you can also see this, let's see, 30. Okay, what happened there? Eval just pick this print 30 out of the string, then process it. That's all, and you get that. So we'll also talk about one more stuff. That's the execute keyword, which is a function, a built-in function rather. It's a method, and what it does is to run the just like the way eval is, it just picks this. It picks the print rather, it picks the print, then process the data. So after that, we have the length, which tells us the length of string or characters also. So, and it's also a keyword. So we have lots of keyword in Python, lots of keyword. That's one of the things that makes Python very easy. So we'll talk about function parameters. A parameter is a variable which is defined as part of the function and is used to provide data within the function itself. So an argument is the value or data passed into the function through the parameter. Don't let this confuse you. A is the parameter. This value here is the argument. That's basically what we are saying. So you're going to see lots of examples. By the time you're going through, you should be able to figure that out. For this example 2, for these multiple parameters, you see you have A and B. You have A and B. Okay, you have A and B, and before the function can work, we need to pass in what? Argument, and that is where we have 5 and 6. So A and B is the parameters, and 5 and 6 is the argument. So let's run this and see what it does. Oh, it gives us 10, and yet we didn't pass any argument here. Okay, the reason why it works is because we've already declared it. At the point of instantiating the variable or the parameter, we also instantiate a value with it. So if you come here where we have multiple parameters, you can also see the what we are saying. Yeah. So we just pass in the values and it processes the information. Then we have using loops with function. Of course, we can process some functions using loop. We can have loops inside functions rather. So in this case, we said count to 16. We have a function count to 16, and we have a for loop inside the function that is supposed to be starting from 1 and then ending at 17. Remember, I told you when the step size is not declared, it is assumed to be 1, so it keeps increasing by 1. So all we simply need to do, we call this function. When we call it, it prints out each of the value in the for loop. Okay, it says count to 10 is not defined. Wow, that's one of the things you need to understand. What we call this is count to 16. So you can't come here and call it a different name. Your function will not respond when you call on it. So let's run it again. You can see it works fine. Okay, then in a situation where we said count to n, and what is n, we have to declare it we have to pass it as a value where when we decide to invoke the function. So let's say I choose to change that to 30 and then I run it. What happened? See, it runs that for me, starting from what, 1 to 30 plus 1, which is 31. But mind you, it will not count the last one, yeah, because all we are asking for is 30. So we now talk about generators and decorators. They are actually very wonderful Python functions, which is very, very important. Whenever a call is made to a Python function, it makes use of the current argument to pass to it. And then after answering the call, it wipes its memory in order to accept another argument from a call. Using the concept of generators, we can make the function remember the arguments. What they are basically saying here is this. You can see when I highlight this variable and put my cursor on it, you can't see anything. Normally it should display a number, but you are not seeing anything like that. Why? Because Python does not functions, they do not store the value. So as you pass in 30, it didn't store it. It just goes ahead, use it to process the information it needs to process, and then what's the next thing? It wipes it from its memory once the output is gone. So, and the reason why it's doing that is to accept another argument from another invocation. In order to bypass that, we can use the yield keyword. The yield keyword helps it to remember the numbers or whatever the value is. And then, so instead of using return, we are no more using return, we are using yield. Yield helps to store that in memory and processes the information. We can always call back on it. And that's why you see in this example, we were able to do this little computation 0, 2, 4, 6, 8, 10. What that is basically doing is that since it holds the value, the previous value, since yield holds the previous value, you can see currently it still holds the value. That's the last I think 76, maybe that was the last one I ran. Let's play with it before I explain it to you. Okay, and one other thing, we have to break it because using the generators, they don't stop. They don't stop, it's infinite. So I'm forcing it to break right now. Okay, I'm forcing it to break and it's trying to restart my runtime. So it's infinite. The memory you have on your computer is finite, but when we are using the generators, they are infinite. So they have to completely stop. You have to force them to stop because it can store the information in using the yield, so it can store and keep processing. I'm thinking of even copying it, then delete it and paste again because it's not responding.